Hello and welcome to Grace Tutorial. In this video lecture, we will be discussing about oxidation and reduction. Well, we will discuss both the concept, that is the classical concept of oxidation and reduction, as well as the electronic concept of oxidation and reduction. First of all, let us discuss the classical concept of oxidation and reduction. Well, let us try to understand what do you mean by this oxidation. Oxidation means it is basically a process which involves the addition of oxygen or removal of hydrogen. Once again, I repeat the definition. Oxidation means the process which involves the addition of oxygen or removal of hydrogen. So what are the examples? Let me give you some of the examples so that it will be easy for you to understand. Look at here. When the magnesium reacts with oxygen, it gives the magnesium oxide. Similarly, when the sulfur reacts with oxygen, it gives sulfur dioxide. If you look at these two examples, here the oxygen has been added in the first reaction as well as in the second reaction. So the addition of oxygen is known as basically the oxidation reaction. So here this is the oxidation reaction and it comes under the addition of oxygen. Similarly, the removal of hydrogen from a substance is also known as the oxidation. So look at the reaction number 3 and reaction number 4. It's very easy to understand, my dear students. Here we have hydrogen sulfide and in the product side we have only sulfur. That means here the hydrogen from the hydrogen sulfide has been removed and the product has been formed, that is only the sulfur. That means the hydrogen has been removed from the hydrogen sulfide to form the sulfur. So this is what the reaction of the removal of the hydrogen. Similarly, if you look at this reaction, reaction number 4, hydrogen sulfide has been treated with the chlorine to give the hydrogen chloride with the sulfur. That means here the hydrogen from the hydrogen sulfide has been removed to give the sulfur as well as the hydrogen chloride. So the hydrogen has been removed from this reaction as well. So this is also an oxidation reaction. So what is this oxidation? Oxidation is nothing but the addition of oxygen. These two are the examples which are mentioned for the addition of oxygen, and these two are the examples which are given for the removal of the hydrogen. Well, this is all about the oxidation. So oxidation simply means the addition of oxygen or removal of hydrogen. So addition of oxygen, the two examples are given here. Similarly, the remaining two examples are given for the removal of hydrogen. So this is all about the classical concept of oxidation. Now let us discuss the next one, that is the reduction. Let me give you the definition of reduction. So what is this reduction? Reduction means the process which involves the addition of hydrogen or removal of oxygen. That means addition of hydrogen to a substance or removal of oxygen from that substance is what basically called the reduction. So let me give you some of the few examples of the reduction so that you can get it very easily. Well, look at here. If you look at the first reaction, we have the bromine. It reacts with the hydrogen sulfide to give the hydrogen bromide along with the sulfur. That means if you look at the first reaction, here we have hydrogen sulfur. Here we have only the bromine, but in the product side we have hydrogen bromide. That means here the addition of hydrogen has been taken place. Similarly, if you look at here we have simply the chlorine, but here we have hydrogen chloride. That means the addition of hydrogen has been taken place. So what is reduction basically? Addition of hydrogen is also called a reduction, or removal of oxygen is also known as a reduction. So these two examples are mentioned for the addition of hydrogen. Similarly, let me give you some another two examples which are mentioned for the removal of the oxygen. Well, if you look at this third number reaction, we have copper oxide, and when this copper oxide reacts with carbon, what happens? We got the copper as well as the carbon monoxide. That means here the oxygen has been removed from the copper oxide to form the copper. if you look at the fourth number reaction, we have ferric oxide. When it reacts with carbon monoxide, what happens? Here this oxygen has been removed from here and we got the ferrous. So this is the removal of the oxygen. So at last, what do we need to understand from this too? The addition of hydrogen or the removal of oxygen is known as the reduction reaction. Now we need to discuss the oxidizing agent as well as the reducing agent. So what is this oxidizing agent? Well, oxidizing agent is the substance which provides oxygen or removes the hydrogen. That means the substance which is used to carry out the oxidation, that substance is basically called oxidizing agent. Let me give you some of the few examples so that you can understand it very easily. Well, if you look at this oxidation reaction, the magnesium reacts with the oxygen to give the magnesium oxide. Similarly, the sulfur reacts with the oxygen to give the sulfur dioxide. And these two reactions we have already discussed in the oxidation reaction. This is oxidation reaction, of course. But what is the oxidizing agent? The substance which is used to carry out the oxidation, that substance is called the oxidizing agent. So, what substance? Which is that substance? It causes the oxidation in this reaction. Well, oxygen is the oxidizing agent in this reaction because it causes the oxidation to both the magnesium as well as the sulfur. Similarly, what do you mean by this reducing agent? Reducing agent is the substance which provides the hydrogen or removes the oxygen. That means the substance which is used to carry out the reduction, that substance is basically called the reducing agent. Look at here, these two examples we have already mentioned in the reduction reaction. Here, in this reaction, the H2S as well as the H2, that means the hydrogen sulfide as well as the hydrogen, act as the reducing agent because it provides the hydrogen. That's why, and these substances are responsible for the reduction. That's why these two substances are the reducing agent here in these two examples. That's all about the oxidizing agent as well as the reducing agent. Now we will discuss the redox reaction. So what is this redox reaction? Let us try to understand it in a very brief manner. Redox reaction means the addition of oxidation and reduction. That means if any reaction purges both the oxidation as well as the reduction, then that reaction is called a redox reaction. Now we will check all of these reactions, whether these reactions purges the oxidation as well as the reduction or not. First of all, let's have a look at the first reaction. Well, if you look at the first reaction, we have zinc oxide. When the zinc oxide reacts with carbon, then what happens? We got the zinc as well as the carbon monoxide. So what happened here in this reaction? Whether these reactions do purchase the oxidation or not, we'll check. And this reaction will purchase the reduction or not, we'll check. Well, look at here. Here we have carbon. In the reactant side, we have carbon. But in the product side, we have carbon monoxide. That means here the addition of the oxygen has been taken place. So once you just recall the definition of the oxidation, addition of oxygen or removal of hydrogen is known as the oxidation. So here it is simply to be said that the carbon here in the reactant side, but in the product side, the oxygen has been added. That means here the oxidation has been taken place. Similarly, if you look at here, in the reactant side we have the zinc oxide, but in the product side we have zinc. So what happened here, my dear students? Here the oxygen has been removed from this substance and we got the zinc. That means here the reduction has been taken place. So this is the reaction where the oxidation as well as the reduction took place. That's why it comes under the redox reaction. Let us take one more example to make you understand it very clearly. We have hydrogen sulfide, similarly sulfur dioxide, and when the hydrogen sulfide and sulfur dioxide reacts together, then what happens? We got the sulfur as well as the water. So what happened here? If you look at this, we have sulfur dioxide, but here we have sulfur. That means here the oxygen has been removed. So this is what the removal of oxygen is known as the reduction. Similarly, if you look at here, we have hydrogen sulfide, but in the product side, we have water. That means here, the oxygen has been added here in this reaction. That means here, the oxidation took place. So this is oxidation. So this is the reaction wherein both the reduction and oxidation has been taken place. So this reaction also comes under the redox reaction. Let us discuss one more reaction to make you very clear. We have manganese dioxide, and when it reacts with hydrogen chloride, we get manganese chloride along with chlorine and 2 water. Look at here, we have manganese dioxide, but here we have manganese chloride. That means here the oxygen has been removed from here. So what happened? Whenever there is a removal of the oxygen, that is what basically called reduction. That means here the reduction has been taken place. Similarly, if you look at here, we have HCl, but in the product side, we have water. That means here the oxygen has been added. So here what happened? The oxidation took place. The oxidation took place. So this is the reaction wherein the oxidation as well as the reduction took place. That's why this reaction also comes under the redox reaction. Let me give you the last example for this so that it will be easy for you to understand. Well, we have ferric oxide. When it reacts with aluminium, what happened? We got the ferrous as well as the aluminium oxide. Look at here, my dear students. Here we have aluminium, but here we have aluminium oxide. That means what happened? Here the oxygen has been added. So the reaction in which the oxygen has been added, the addition of oxygen, that is what basically called oxidation. So here the oxidation has been taken place. Similarly, we have Fe2O3, but it has been changed into Fe. That means here the oxygen has been removed. So the removal of oxygen is known as the reduction. So this is also the reaction wherein the oxygen as well as oxidation as well as the reduction has been taken place. That's why this reaction also comes under the redox reaction. So what is this redox reaction? Redox reaction is nothing but the addition, oxidation as well as the reduction. The reaction which possesses both the oxidation as well as the reduction, that reaction is called the redox reaction. And in all these examples, what did we understand? All these examples possesses both this oxidation as well as the reduction. That's why all these examples comes under the redox reaction. So this is all about the redox reaction. Now we will discuss the electronic concept of oxidation as well as the reduction. So what is this oxidation according to this electronic concept? Because before we had discussed the classical concept of oxidation and reduction. Now we are discussing the electronic concept of oxidation and reduction. Well, oxidation is defined as the process which involves the loss of electrons by an atom or ion. But we need to remember here, during this oxidation, the loss of electrons may result in increase in the number, increase in the positive charge, increase in positive charge, and the loss of electrons may also result in decrease in negative charge. Well, we need to understand that what is this oxidation according to this electronic concept. It's very simple. Whenever there is a chance of loss of electrons, so the loss of electrons by an atom or by the ion, that is called the oxidation. But during this oxidation, what happens? The loss of electrons may result in the increase in the positive charge as well as the decrease in the negative charge. Now let's look at some of the examples so that it will be easy for you to understand. Well, if you look at the first example, here we have magnesium. When the magnesium loses the 2 electrons, then it forms magnesium ion, that is Mg2+. Similarly, we have Sn2+ here, and after losing the electrons, it has become Sn4+. Similarly, we have Fe2+, but after losing 1 electron, it has become Fe3 plus. That means whenever there is the loss of electrons, then what happens? There is a chance of increasing the positive charge. So if you look at here, the positive charge is 2 plus, but here the charge is 4 plus. That means the positive charge is being increased due to the loss of electrons. Similarly, during this oxidation, the loss of electrons may also result in the decrease in the negative charge. How? Have a look. Here we have S2 minus, but in the product side we have only S. That means the negative charge has been decreased. Similarly, we have MnO4 2 minus, but here in the product side we have MnO4 just minus. That means minus 1. So what we need to understand from here, oxidation is nothing but the loss of electrons by the atom or by the ion, but that results in the increase in the positive charge as well as the decrease in the negative charge. Well, that's all about the electronic concept of the oxidation. Now we will so how can we define the electronic concept of the reduction? Well, it's very simple to understand, my dear students. Reduction is defined as the process which involves the gain of the electrons by the atom or by the ion. But during this reduction, what happens? There is a chance of decrease in the positive charge and increase in the negative charge. Let's have a look at some of the examples so that you can get it very easily. Well, if you look at here, we have Hg2 plus, but in the reactant side we have Hg2 plus, but in the product side we have Hg plus. That means there is a decrease in the positive charge in the reaction. Similarly, we have Cu2 plus, and due to the gain of the 2 electrons, here it has become copper. That means there is a decrease in the positive charge. Similarly, we have another 2 examples, but here this is something different. There is an increase in the negative charge. How? When the chlorine gains the 2 electrons, then it becomes 2 chloride. That means there is an increase in the negative charge. Similarly, we have MnO4 minus, and due to the gain of the 1 electron, what happens? We have got MnO4 2 minus. That means there is a chance of here the increase in the negative charge. So this is all about the 4 different examples of the reduction, and the first 2 examples shows that there is a decrease in the positive charge, and the last 3 and 4, last 2 examples show that there is increase in the negative charge. So this is all about the electronic concept of the reduction. Now we will discuss the electronic concept of the redox reaction. Now let us discuss the electronic concept of the redox reaction. So what is this redox reaction? When the oxidation as well as the reduction takes place in one reaction, that is what called the redox reactions. But what is the electronic concept of this redox reactions? Well, look at the first example so that you can understand it very easily. We have hydrogen sulfide, and when this hydrogen sulfide reacts with ferric chloride, we got the ferrous chloride with hydrogen chloride as well as the sulfur. So if you observe it very carefully, that here the hydrogen sulfide, due to the loss of the 2 electrons, that from hydrogen sulfide to sulfur has been obtained. That means the oxidation has been taken place. But here the ferric chloride has been converted into the ferrous chloride due to the gain of the electrons. So this is a process called the reduction. That means here in this one reaction we have both the oxidation as well as the reduction. Therefore, this reaction is called a redox reaction. Similarly, let us have a look at one more example so that you can get it very clearly. We have zinc, and when this zinc reacts with the copper ion, then what happens with the zinc ion as well as the copper? So what happened here? That the zinc has been oxidized, losing the 2 electrons. Losing the 2 electrons, the zinc has been oxidized to Zn2+. Similarly, gaining the 2 electrons, the copper Cu2+ has been reduced to Cu. Gaining the 2 electrons, it has been, what happened here? Gaining the 2 electrons, it has been changed into Cu. That means here the reduction has been taken place. So, the zinc, due to the loss of the 2 electrons and the process of the oxidation, converted into Zn2+, and the Cu2+, due to the gain of the 2 electrons, and the loss due to the gain of the 2 electrons and the process of this reduction, it has been changed into Cu. That means this reaction possesses both the reduction as well as the oxidation. So these are the two different examples of the redox reaction. We will be discussing about both the corrosion as well as the rancidity and its various effects. First of all, let us try to understand what do you mean by the corrosion. Well, the process of the slow and the gradual conversion of metal into its compound by the attack of air and the moisture, that means the water which is present in the atmosphere, is known as the corrosion. What are the various examples of the corrosion? Well, the black coating on the silver, well, the green coating on the copper, as well as the red-brown coating on the iron are the examples of some of the corrosions of the silver, copper, as well as the iron. And the corrosion of iron is also known as the rusting. Well, both the corrosion as well as the rusting are very harmful and cause damage to lots of buildings, railway tracks, automobiles, and all other objects as well as the materials where the metals are used. Well, that's all about the corrosion. Now let us discuss about the rancidity. What do you mean by this rancidity? When the food items are kept out for a long time, then what happens? Due to the presence of the fats and oils which is present in the food items, the food will be converted into such an unpleasant smell, and its taste also will be changed. That means it becomes rancid, and the process is called the rancidity. Well, that means the condition, the aerial condition which is produced by the oxidation of the fats and oils which is produced in the food item will completely convert its taste and the smell. That means the taste and the smell will be changed into a very different way due to the oxidation process, and that condition is what basically called the rancidity. Well, we need to understand one of the most important thing here. What are the various ways that we can reduce the development of the rancidity in the food items? That means what are the various ways we need to find out to step up or to prevent the rancidity or to retard the rancidity. Well, I have the step number 1. By adding the antioxidants to the food items. Well, whenever you add the antioxidants to the food items, then there won't be the chance of getting oxidized. That means there won't be the chances of oxidation of the food items, so that the food items will be very safe. So what are the antioxidants we need to add? Well, we have the two antioxidants, that is the BHA, that is the butylated hydroxyanidrol and butylated hydroxytoluene. When these antioxidants are added to the food items, then what happens? The oxidation does not take place in the fats and oils which is present in the food item, so that the food will be very much safe. That means the development of the rancidity will be prevented. Similarly, we have one more way to prevent the rancidity, that is by filling the nitrogen gas. Basically, this method is mostly used by lots of the manufacturers, especially the manufacturers of the chips, the potato chips, or the various chip substances. Well, whenever the nitrogen gas is filled in that substance, then there is no chance of getting oxidized. That means the oxidation does not take place, and that will make the food very much safe. Similarly, we have one more way, that is by keeping it in the refrigerator. When any food item is kept in the refrigerator, then that will be very much safe, because due to the low temperature in the refrigerator, that means the oxidation will be reduced. There is the reduction of the oxidation process will be reduced, so that there is no chance of getting oxidized of both the fats as well as the oils which is present in the food items. So if you will keep any food items in the refrigerator, then that will keep the food items very safe due to its low temperature. We have one more way, that is by storing the food in airtight containers. Well, whenever you store the food in the airtight containers, then the oxidation does not take place. So, in order to get oxidized, what happens? The food needs to be kept out for a long time, and by the attack of by the attack of the oxygen, that means when the oxygen attacks on the food items, then that will be easily get into oxidized. But whenever the food is stored in the airtight container, the oxidation cannot take place. That means the development of the rancidity can also be prevented, or it can also be retarded by storing the food items in the airtight container. Similarly, we have another way, that is by storing the foods away from the light. Whenever you keep the foods away from the light, then there is no chance of getting oxidation. And that process is also one of the best way. This is also one of the best way to prevent or to retard the rancidity. So here, in this section, we need to understand that what is rancidity and what are the various methods to prevent the rancidity. The rancidity is nothing but a condition in which the fats and oils which is present in the food item will get oxidized. Due to the oxidation, its smell and the taste will be completely changed into such unpleasant. That's why we need to follow these various steps to prevent the rancidity. This is all about the corrosion as well as the rancidity from this part. Thanks very much for watching, and if you do like, please share and subscribe to our YouTube channel.